Try it this way. All right, we'll try it this way. All right, thank you everyone for coming to today's session. Threat detection on AWS and introduction to Amazon GuardDuty. This one's not working. Yep. Oh, there it is. Something happened. Now it's black. Here it goes. All right, there it goes. Now it's working.
That yours?
Yep, that's okay. It. Thanks. So yeah, welcome to today's session, Introduction to Amazon GuardDuty. So before we dive really deep into the specifics on GuardDuty itself, a lot of times it's really kind of instructive and useful to understand how this fits into all of our other security services. So as you can kind of see, we have quite a number of different security services at AWS. And so one way to kind of help visualize those is to apply them to the NIST model of identify, protect, detect, respond, and recover. GuardDuty fits in as a detective control. However, as we go through the presentation, especially when we get to the section towards the end, when we look about how we respond to some of these detections that come out of GuardDuty, we'll start to leverage some of the other adjacent services, specifically on the protect and the respond side. So what is GuardDuty from a very high level? GuardDuty is a fully managed threat detection service for your workloads and your AWS accounts themselves. And we're specifically looking at identifying threats that are known malicious or represent behavior that is sufficiently unusual that it should be looked at. Out of curiosity, is there anyone here already using GuardDuty on their account? All right, yeah, we got a good number. And that doesn't really surprise me. So we released GuardDuty at reInvent 2017, so just about 18 months ago. It's been one of our fastest growing services, and we have quite a number of customers that are using it. We are monitoring primarily API calls, as well as the network traffic that's coming to and from your instances. And we really decided to build this service because we needed something that was a purpose-built threat detection service, whereas a lot of legacy tools or other detection methods were really only very network-focused. We needed something for Amazon, for AWS, that was looking not only at the network side of things, but also understood that you need to have some ability to detect malicious activity through API activity, in addition to specifically just looking at network traffic. So from a very high level, how do we detect threats with GuardDuty? So our detection starts with 3 primary data sources. The first data source is VPC flow logs. If you're not familiar with flow logs, one thing that I do want to point out is you don't have to turn any of these services on. So we get access to the log data associated with these through an independent channel behind the scenes directly from the service that creates them. So you don't have to actually administer or enable or configure any of these log sources. We automatically get that data into the GuardDuty service as soon as you enable GuardDuty itself. So we look at flow logs. We also look at your DNS logs. DNS logs are all of the domains that instances within your environment are querying, and those two help us really understand the network traffic, right? So we can see who you're communicating with, as well as what domains you're looking up. And then lastly, we look at CloudTrail. So CloudTrail, if you're not familiar with it, is essentially an audit trail of all of the API activity that takes place within your account. The feeds from all of these log services go into our backend. Our backend consists of 2 different sets of fleets. So we have what we call a stateless fleet and a stateful fleet. And the stateless one is really things that we can detect immediately through that one particular piece of data. So things like an IP match on a threat list. If you look more at the stateful, these are more of the behavioral detections. So these are detections that we have to contain state for that particular instance or that particular IAM user or role to understand whether or not that behavior is normal or not. And then the output of that is what we call a finding. And one of the things that we do with our findings is we try to aggregate them. We also try to minimize the amount of noise, and we try to make it very simple as far as the severity. So we have kind of a stoplight method, right? So low, medium, and high. And we'll talk about how we can respond to those later on in the presentation as well. If we dig into these three data sources a little deeper, so flow logs, as I mentioned, you don't have to turn these on. That sometimes is a concern from customers because in large environments, flow logs can get expensive. Again, we get access to these without you have to enable them, which also means you don't have to configure anything. So that's really helpful, especially in large numbers of accounts. You don't have to worry about whether or not somebody has disabled one of the services that we depend on. What we get from flow logs is we get information that's very similar to NetFlow, if you're familiar with that. Essentially, we get the IP address, we get the port from the source, as well as the IP and port for the destination, the protocol that's in use, as well as how much data was transferred in that session. And with this information, we're able to actually apply the threat intelligence feeds to those to look for communication to no malicious IPs, either inbound or outbound, as well as to build behavioral models for your individual instances themselves to determine whether or not the amount of data that's being sent by that instance is normal, or if it's communicating outbound on a port that is unusual. DNS logs is somewhat of a special log source currently, so there is no customer-facing way to get access to these logs today. GuardDuty is the only way to get or have the DNS query logs inside your VPC get inspected. So these are separate from the external Route 53 query logs. This is the domains that are being queried by the instances within your environment. And this is really useful because if you have an instance that gets compromised, it might query domains associated with things like Bitcoin mining or other associated threats, or also to detect compromised instances in that fashion. The last one, of course, is CloudTrail. Again, most everyone will have CloudTrail turned on, but again, we get access to CloudTrail through an independent stream. And CloudTrail gives us a history of all of the API activity that takes place in your account, all the console logins. And what we're looking for here is things like compromised credentials, looking for unusual activity, logins to the console or use of APIs from locations that are unusual, users that are performing activities or trying to perform activities that they don't ordinarily perform. Or the exfiltration of instance-based credentials is yet another thing that we could detect with CloudTrail to make sure that if somebody compromises an instance and gets IAM instance credentials, that they can't use them outside of AWS. One other thing to make note on this is we don't store any of this data. So this is one of the ways that we also keep our costs down for GuardDuty, is all of this data is streamed to us from the internal source. We process it in memory, and then we destroy it. So we don't actually maintain any of this data as part of the service. The only exception to that, of course, would be if one of those log entries creates a finding. The information about that finding obviously goes in the finding itself, and then we store that for you. Some of the key benefits or kind of selling points of GuardDuty itself. One of the first ones is simplicity, right? In order to get GuardDuty turned on, there really is only a single button. There's nothing to configure or no administration to do. And this is one of the things that customers tell us they like the most about it, is there's absolutely no changes to your environment. One of the challenges a lot of times with security tools is you end up having to install agents or put appliances somewhere in the path. And because we're doing all of our analysis on log data that we're getting from outside of your environment, there's absolutely no changes to anything that you're running. Nothing to install, no architectural changes. As soon as you turn on the GuardDuty service with that single button, we start collecting that data into our account on the back end, and you start getting protection for your services. We've talked to a number of security teams where they've enabled GuardDuty on their application teams' accounts, and they didn't even realize it was turned on. And because we're doing everything out of band, it gives those security teams that ability to turn on the service without having to really do a lot of coordination with the application owner or worry about if it's going to impact performance or cause any kind of challenges with the application itself. The other benefit of, again, being completely out of band is it allows us to do continuous monitoring. So as you create new VPCs or if you create new instances, there's no agent that you have to go and deploy or keep up to date. You don't have to make sure that a new VPC is added in scope or anything of that nature. When you enable GuardDuty on an account in a particular region, we immediately start protecting all of the assets that are part of that particular account in that region, and it happens continuously regardless of if you create new ones. Thirdly, it is a global service, so we are in all of the commercial regions. We also have stated that we will be available in new regions relatively shortly after the region launch, if not at region launch. And we think this is important because we don't want customers to have to operate in regions without having the protection that GuardDuty can provide them. The types of threats that we detect, again, we're going to detect known threats that we're going to look at through threat intelligence, and we'll dive into that in a minute, as well as unknown threats through monitoring the behavior of your users and your instances. The last box down there is yet another thing that customers tell us they really, really like, and this is a feature that we have that's called the master and member on GuardDuty. So in the console, you can go and associate a GuardDuty account with a master. And you can choose any account to be a master. It's not tied to any other service. Generally speaking, this is a security account, some sort of a centralized logging account. And when you do that, the member accounts will be able to still see all of their findings, but the master account gets to see findings across the entire organization. And this is really useful because you allow the individual line of business owners, the people that own those applications, to still be able to go in the console. They can see their own findings. They can be responsible for the security events that are happening in their account. But from a security team perspective, you can see a global view across all of your accounts. You can also then have all of those go out to a downstream system from one single spot. So you don't need to collect events from 100 different accounts. If you have 100 accounts, you make them all members of a single master. And in order to collect all of those as a security team, you only have to look at it from the master account itself. Also, it allows you to prevent member accounts from taking certain actions, like creating whitelists or suppression filters, right? So it puts that control into the centralized security team's account. So if we look at the different types of threats that we can detect, the first type is we consider known threats. And we detect known threats by applying threat intelligence feeds. And threat intelligence feeds is really a fancy way of saying IPs and domains that we know do bad things or are involved in unwanted activity. These feeds are constantly being updated, right? So the fidelity on these, you have to constantly make sure that you're getting updates, otherwise they get stale. We get our threat intelligence from 3 different sources. So first off, as you might imagine, at AWS, we have some of our own threat intelligence that we generate by seeing a lot of traffic that happens on the internet itself. That is something customers have been asking us for a long time to externalize. Unfortunately, it's not really an easy thing to do in a one-off type situation, but GuardDuty gives us a secure and scalable way to share that intelligence with customers through a service. The second piece is our partners. So we partner with Proofpoint and CrowdStrike. And so when you turn on GuardDuty, you get Proofpoint and CrowdStrike's threat intelligence feeds with no additional cost. So we apply both of those. And again, we manage the updates to all of those feeds. So there's nothing that you have to go and apply updates to or to make sure you're using the latest version. It just happens automatically. Then customer provided. So we allow customers to upload or apply their own threat intelligence. We see some of the larger customers or customers that have certain industries where they have very specific threat intelligence that is important to them. And you can upload that either through API or in the console from an S3 bucket. And we will apply that only to your account. So it doesn't apply to everyone else. A lot of times there's agreements that you're not allowed to share some of that intelligence. So we only apply those detections to your specific accounts. If you have the master member set up, we will apply it to all of your member accounts as well, but we don't share it across customers. These IPs and domains that we're looking at gives us the ability to, based on the DNS logs or the flow logs, identify communication with known infected hosts, command and control. Lately, we're seeing a lot of Bitcoin activity from infected machines. And it allows us to raise findings based on those. The other thing that we're looking at is unknown threats. And unknown threats are kind of important because we don't have a pattern to match those, but within the AWS, if we do all of the baselining and we look at some machine learning against those logs, we're able to identify behavior that is sufficiently outside the norm that it warrants some investigation. We're looking at, for things like this, again, unusual ports, unusual API activity, unusual logins, as well as unusual data transfer out that could indicate data exfiltration. One piece of caution that we've learned over the time too is when you enable the GuardDuty service, the threat intelligence findings are automatically start working because we're applying the log feeds directly to feed. These do take some training time. So when you first enable the service, you're not going to start getting behavior findings immediately. It does take up to 14 days for us to build a proper baseline that we can generate these findings without causing sufficient false positives. So one word of warning, and we've seen people do this, don't turn on the service and then start doing unusual things, because one, you're not going to get a finding for it, and two, you're now putting that into our models. So make sure that you wait for a while before you try to trigger any of these findings. When we look at the types of findings from a compromise standpoint, they really fall into three different broad categories. So the first one is reconnaissance. These are things that take place before a successful attack. So recons would be port probes from known scanners or known malicious IP addresses on the internet. Instances within your environment that are doing port scans, right? They're looking for other instances that they might be able to do lateral movement to. Or network permissions or resource permission discovery. So this is API activity where somebody is trying to figure out what permissions they have or what the network security group or network ACL rules are set for. Again, activity that you would do if you weren't really familiar with an environment, but you wanted to figure out what you could do with the credentials that you've obtained. The second two are really more post-compromise activity. So the first one is the reconnaissance before something bad has happened. The last two, something bad has already happened and we're detecting behavior that is indicative of an actual compromise. So from an instance perspective, it could be things like denial of service traffic. And it's important to note that this is not an inbound denial of service. If you are looking for denial of service inbound, that would be the shield service. What we're looking for in this is traffic from your instance that looks like it's part of a botnet that's participating in a denial of service attack. Command and control activity, so communicating with IPs or domains that we know are hosting active CNC for botnets. Bitcoin activity, again, one that we see quite a bit of. Another one I'll talk about is outbound Tor traffic, right? So the Tor network is the way to do anonymization of your browsing. If you're running a public website, having inbound Tor traffic might not be a problem for you. That might be perfectly okay. However, there's not usually a lot of good reasons to make outbound Tor connections from within the Amazon environment, right? Somebody's on that box and they're trying to communicate outbound in a way that's anonymizing that. That's generally something that you probably want to look at. And then the third category is account compromise. So this is activity that is generally going to be based on the machine learning models. So again, make sure you give us time to build these. But these are changes to the network rules. So security group changes, network ACL changes, IAM permission changes that are unusual, come from an unusual user or an unusual location. Or changes to the security of the account, like changing your password policy to make it weaker, or trying to disable things like CloudTrail, right? These are all things that an attacker might do to try to hide their tracks. And so those are all things that we would flag as a potential account compromise and something that you would want to go ahead and give a look. When we create the findings, we create them under what we call purpose classes. So the threat class, it tells you pretty much what the purpose of that particular attack is trying to do. So whether or not it's a backdoor, a cryptocurrency, recon, right? So these are all the different classifications, and it makes it really easy when you get one of these findings to help classify them. So the taxonomy that we use will start with the kind of class, then the resource type that's affected, and then what the actual finding name was. But this is useful to break down because you might have certain types of findings that you want to prioritize from it, for example, right? Or to send to different teams, and you can do that based on the filters that we'll talk about here in a minute. And you can consume all of these through our console. So we have a console for GuardDuty. One thing you'll notice here when you look at the console is we have the finding type, so you can see that threat class and then what type of resource was affected. On the right-hand side, you'll get all of the details that are in the finding itself. Anything that's got a hyperlink will bring you directly to that resource. One of the other things that's important is you'll notice in that far column you see the word count, or the column for count. And that is one of the aggregations that we do to help reduce the amount of noise. Anyone who's ever used like a traditional network IDS is probably familiar with kind of alert fatigue, where they just send out constant streams of alerts. And we really try to reduce that noise by doing aggregation. So I'll give one example. You see the SSH brute force. That's happened 36 times. Well, the simple fact of the matter is, if you leave SSH open to the internet, it's going to happen a whole lot more than 36 times. It's going to happen pretty much continuously, right? And there's not really a lot of point in us telling you every 5 seconds that someone new has come along and tried to hit on that port, right? The fact that that's happening, it's happening because you left the security group open. So instead of constantly streaming alerts at you, we'll send you the one initially when it first happens. And then we allow you to decide how frequently you want us to tell you if it happens again. The default is 6 hours, and then you can change it down to 15 minutes. But again, it's much more useful for us to tell you once and give you time to fix it. If you haven't changed that security group, then it will still be happening. And we'll send another notification after 6 hours or 1 hour or 15 minutes, depending on how you have that set up. The other thing I'd call out from the console is the filter criteria. So for most of our consoles, filters is just a UI experience. One thing that's unique to kind of GuardDuty filters is you can save those filters as auto archives. That's why you can kind of see it says save filters and /auto archive. The auto archive capability allows you to decide that there might be certain circumstances where you don't want to be alerted to something. So, for example, if I wasn't going to correct that security group, if I wasn't going to close that port down, let's say that's my Bastion host, and I've hardened it, and I know that it's going to be open to the internet, and I'm just accepting the fact that it's going to constantly get brute forced. I can create a filter based on the tags, the AMI, the VPC. You can get very, very specific, and then the finding type, and save that as an auto archive filter. When you save an auto archive filter, we will create the finding. You can view them by changing that current to archive in the console. But importantly, we won't send out a CloudWatch event. So it will not go to your downstream alerting systems or your ticketing system or whatever you have consuming the GuardDuty findings. You won't get those alerts. And so it's a way essentially of suppressing a particular finding based on a set of criteria that you can be very specific with the filter bar. The findings themselves also, again, are available in JSON through our API. So this allows you to call our API and consume them in code yourself. However, most of the time what we see is customers retrieve them directly through CloudWatch events. So CloudWatch events, if you're not familiar with that particular service, it is a subservice under CloudWatch, but it's essentially an event bus. And it allows GuardDuty as well as other services to send events to CloudWatch events. And CloudWatch events will send them on to other services. In this case, specifically, we mostly use Lambda or step functions. This, again, is all aggregated. So when those events happen multiple times, we don't send those alerts. Unless it's within the 6 hour, 1 hour, 15 minute windows that you've chose. And it also, from a testing standpoint, you can go ahead and send sample findings to CloudWatch events as well. So in the console, there is a way to generate a sample set of events. And that could be really useful if you have automation on the other side of this CloudWatch event stream. You might want to test what every single finding will do in your automation. And so generating the sample of findings in the console will allow you to do that without having to try to manually trigger every single type of event. Right? So this essentially is what we end up looking at, and to take actions on all of these findings. The typical scenario that we see is GuardDuty, again, CloudWatch events, triggering Lambda or also step functions. Those are pretty much the two typical ones. Some partners use SNS. but Lambda really gives you a little bit more freedom as to what type of automation you want to perform. Typical integrations that we have are upstream for SIMs or partner tools. So you might have saw on the console that we had a link to a partner page, and we have over 20 different partners that have built integrations with GuardDuty. Some of those are to consume or to visualize findings. Some of them provide additional context to findings or integrate with blocking technologies. Right? There's a lot of partners that have built a lot of cool tools, and most of them are actually out on the show floor. So if you have time, you can talk to them after the session. It also, though, gives you the ability to do some automated remediation or response. And we'll look at a few different ways that you can take these findings, consume them, and then take some sort of an action to help mitigate or prevent a future finding from occurring. When we do this, we're going to look primarily at 3 other adjacent services. AWS Lambda. So if you're not familiar with Lambda, Lambda is our functions as a service, so it allows you to run function code with zero infrastructure in your account. You essentially give us a piece of code, we execute it for you. The second one that we're going to use is Systems Manager. So Systems Manager allows us to take action and get information off of an instance because it has an agent that runs on the box. You can send it commands, you can ask it to query information, things of that nature. And then the third one is Inspector. So again, through Lambda, we can actually trigger Inspector to do a vulnerability assessment. So this could tell you whether or not an instance is missing a bunch of patches, for example, from a vulnerability standpoint. So using these 3 services, the way we tie this all together, again, is first, Amazon GuardDuty creates the findings. We do our aggregation, and we do our noise reduction to make sure that we're not sending continuous streams of alerts. Goes into CloudWatch events, and we're going to trigger Lambda functions. Again, you can also do step functions to trigger Lambda functions for more complex integrations. From there, we have all of our partner integrations, some automated responses, and really anything you want. Again, because Lambda executes whatever code you get it. So anything that you can express in code, you can take as an action. Some examples that we'll go through here. So these are some of the more popular ones. This one, we have also written a blog post specifically on this kind of use case that has some of the sample code that's used in this diagram. So the concept here is if you have an application that's running behind an AWS WAF, you might have 2 different types of threats that we can think about. So if I'm getting port probe, let's say on HTTP or HTTPS, and a port probe is coming from a malicious actor on the internet, I might want to be able to block them. And so when GuardDuty sees that, hey, this is a known malicious IP, maybe they're involved in scanners on the internet, we can create that finding. That finding will go to step functions, which, because of the fact it's an inbound connection and it's for a port probe, it will send that over to an IP block list in AWS WAF, which will then prevent that actor from getting any further communications. When we do this, there's also a DynamoDB table on the back end that has the set of IPs and the time, and then you basically configure how long you want to shun that IP address for. And what will happen is that Lambda function will also then remove those blacklists after they're no longer, after they time out. Another thing you might want to look at is modifying networks ACLs. So security groups don't support negative rules, right? But network ACLs do. So if you have, let's say, an instance that we see traffic going from the instance outbound to a command and control server, I might want to sever that command and control traffic by putting an outbound block list on my network ACL and prevent any of the instances inside that subnet from communicating with that IP address. This could also be done, again, for Tor traffic outbound, Bitcoin traffic outbound, anything that's outbound traffic from an instance, you can block, again, using a network ACL. You can also block inbound traffic from those as well if you wanted to block both sides. So if you're not ready to do blocking actions, one of the other things that we could do that's very useful is utilize some of this automation to help gather information for a human incident responder. So if instead of actually putting blocks in place, you want to have somebody who's going to go and actually investigate or look at what's happening on that instance, you generally are going to have a set of commands or a set of activities that they do probably immediately when they go look at a host. And we can automate a lot of those and give that information directly to that SOC analyst or that incident responder as part of the finding itself. So when the finding creates itself, we will have a Lambda function that does a couple things in this case. One, I might want to take a snapshot of that volume immediately, right? So I get a point in time snapshot of that volume, which I can then attach to an offline another instance that I can do some investigation with so it's not running. I can also then use Systems Manager to collect information off that instance for me. So I could run scripts that give me the list of recently changed files, what processes are listening on which ports, netstat to see what outbound connections you have going, the full process list itself. You can even go and do something like Lime and use to get a full memory capture. All of this then can go and you can upload to like an S3 bucket or send to a queue and have that information associated with the finding. So that way, when it gets to somebody who's going to do an investigation, a lot of the activities that they might have already done manually have been performed for them, and they have that in front of them straight away. The kind of perfect end state in a completely stateless environment is even a little bit more automated. So this is one where we see a lot of customers want to get here, but it's very difficult to do, and it really relies on a fully stateless auto-scaling type architecture. So if you have an architecture that is completely stateless, you don't have any information that's on a host that is important to the application itself, and you're deployed 100% in auto-scaling, you can automatically remediate and replace instances, essentially. So in this case, if I had a finding about an instance that was potentially compromised, I could detach it from its auto-scaling group, which means we'll have that instance get replaced by auto-scaling, so you keep the availability up. Next, you might want to check and see if it has an IAM role, right? Because if the instance is potentially compromised and it's got an IAM role attached to it, there's a potential that somebody could use those credentials maliciously. So we can remove the role from the instance itself, snapshot the volume again, so you have a forensic copy of what was on the instance. You can then replace its security group with one that has deny rules. So that way, if there is any process that's running on it, it can no longer communicate or accept commands from an outside. And then attach a forensics network interface. So the idea here is you have a subnet inside your environment that has a hardened host on it, and you attach an ENI to this that is in that subnet that only allows SSH traffic, for example. So that way you can go onto an instance, you can SSH safely into that, but it can't send any traffic back out, right? You only allow kind of that inbound SSH from one of those instances that's going to go and be used to identify what was wrong with it. When you're all done, then you can simply terminate it, right? When you're okay doing that, because auto-scaling would have already replaced it. Again, this requires a very, very specific type of architecture before you can get to that state. So one thing I will say, before you try to enable automatic remediation, a few things that are really important. First and foremost, not every single one of those is going to work for everything, right? So yeah, you got to pick the right type of action based on the affected resource and the type of finding, right? Especially things that are behavioral based. So something that's unusual might not necessarily be malicious. So there's different activities that you might want to take based on the finding type, but also the finding resource, or the resource that's actually affected. So pick the right one. Don't try to apply the same action against every single account in your environment. I will say most of our customers are in the notify and ticket phase, right? So for most cases, you want to notify the resource owner or the IAM user itself, or open a ticket to somebody to do further investigation. The isolation and terminate and replace are, again, much more aggressive actions. But no matter what, one of the things that is very key in order to enable all of these is having a good tagging strategy. So a lot of times, especially when you have a security team that's getting access to all of these findings, and they're not the actual application owner themselves, if there's not good tagging associated and it's not consistent, then they won't have the context that they need in order to realize which action. Also, if the tagging is not consistent, you can't use code or automation in order to determine how you're going to route that. So even if you're going to go for just a ticketing, you have to know who to ticket. Right? You need to know who owns that resource or what that resource is used for in order to properly route any sort of notification. So this is a very important thing, and this has more uses than just GuardDuty, right? In general, you will be a lot happier from both a security and an operational standpoint if you have a well-defined and consistently enforced tagging strategy. The third one, it's incumbent upon us as security professionals then to work with those application owners to understand whether or not we can ticket them, whether or not we can isolate those instances, right? In order to understand what type of action or how you should respond to individual findings themselves. The security team needs to have at least some interaction with the application owners to understand, what that instance does, or what that particular role or user is supposed to do. And this is something we should do anyways. This is just good practice. So lastly, I would say, again, start with notifications and ticketing. That is where we see the bulk of our users do right now. And if you are going to move into an automated remediation type framework, you want to do so deliberately and slowly to make sure that you don't accidentally cause any sort of availability concerns. So thank you for coming today. We have some time left, so if there's any questions, I will be over here on the side and happy to answer any questions that anyone has. And also do please make sure that you complete the session survey in the mobile app. Thanks.